In this video, we're going to be finding the zeros of a polynomial function, specifically of f of x equals x to the fourth minus 3x to the third plus 6x squared plus 2x minus 60, given that 1 plus 3i is a factor of f. Now, from what we learned about factors and that complex zeros occur in conjugate pairs, that also tells us that 1 minus 3i is also a factor of f. So first, we're going to start off by writing those as factors. So we're going to have x minus 1 plus 3i in factored form times x minus 1 minus 3i in factored form. And from here, we'll go ahead and FOIL those. So we'll have x times x is x squared, and then we'll have x times negative 1 minus 3i. So we'll have negative x times 1 minus 3i. Then we'll have negative 1 plus 3i times x, which will give us negative x times 1 plus 3i. And then we'll have a negative 1 plus 3i times a negative 1 minus 3i. So we know it's going to be a positive. And from here, when we look at those, we have 1 plus 3i times 1 minus 3i. We have conjugates. So we're able to do our a squared minus b squared, or 1 minus 3i squared, which is 1 minus 9 times negative 1, or 1 plus 9, which is 10. So plus 10. So this was our blue step, right? All right. So now from here, we want to go ahead and we want to distribute our negative x's. And so that is going to give us, we're still going to have our x squared. Then we have minus x plus 3xi minus x plus 3xi. Oh, that shouldn't be a plus. That should be a minus. That's my mistake, because a negative times a positive is a negative. So minus 3xi. And then we have our plus 10. So we're going to combine our like terms. So we have x squared. And so that's the only one of that. Then we have a negative x and a negative x, so minus 2x. We'll get rid of those. Then we have a positive 3xi and a negative 3xi, so those will cancel out. And then we have our plus 10 that's going to be just kind of by itself. So from here, what we're going to do is we're going to do some long division now. Okay, we're going to do some long division. So let me give us just a little bit more room. We can make this a little bit smaller. There we go. Move it over. Okay, so what we're going to do is we're going to take our polynomial here and we're going to divide it by our zeros. So we're going to take our coefficients, which are 1, or I guess without doing synthetic, so let's go ahead and let's just write it down. We're doing x to the fourth minus 3x to the third plus 6x squared plus 2x minus 60, and we're going to be dividing that by our x squared minus 2x plus 10. All right, so go ahead and scoot this over so we have some room to work. So we're going to take our first term, which is x to the fourth, and we're going to divide it by x squared. So we're going to take x to the fourth divided by x squared, and that's going to give us an x squared. So we're going to put that on top of our squared term. Then we need to multiply to all three pieces. So x squared times x squared is x to the fourth. X squared times negative 2x is a negative 2x to the third. And x squared times 10 is going to be a 10x squared. Then we need to change all of our symbols to the opposite. And then we can add. So we're going to add those together now. That should cross out. So we have a negative x to the third minus 4x squared. It'll bring down our next number, so plus 2x. Now we're going to divide negative x to the third by x squared. So negative x to the third divided by x squared is going to give us a negative x. So minus x. Now the same thing, we're going to multiply to all three pieces here. So negative x squared times, negative x times x squared is a negative x to the third. Negative x times negative 2x is a positive 2x squared. And a negative x times 10 is a negative 10x. But we have to go in and change all the symbols to their opposite things, and then we can add those. So our x to the thirds cancel out, and then we're going to have a negative 6x squared plus 12x, and we'll bring down our 60. And now we're going to take our negative 6x squared and divide it by x squared. So we're going to take our negative 6x squared and divide that by x squared, and we're going to get a negative 6. And so we're going to multiply that to all three pieces as well. So negative 6 times x squared is a negative 6x squared. Negative 6 times negative 2 is a positive 12x. And negative 6 times 10 is a negative 60. But remember, we have to go in and change all of our symbols to their opposites. Then we can add those, which is going to give us, that's going to go away, and that goes away, and that. So we're going to have a remainder of 0. So basically, what we're saying is that if we take this number and we multiply it with this number, we're going to get this. Okay, that's what we're saying there, right? That green and blue, that yellow and blue go together to make green. So we're going to write that down as factors. I'm going to bring this back over here, give ourselves a little bit more room. All right, so we're going to take our x squared minus 2x plus 10, right? I'm going to take that, and I'm going to take the x squared minus x minus 6 that we got from up here, and now we want to try and break each of those down. So we first want to know, are there two numbers that will multiply to 10 and add to a negative 2? Like, will 1 and 10 do it? Nope. What about 2 and 5? Nope. And remember that what we're trying to do right now is we're trying to find all the zeros, right? We're trying to find all of our zeros. So we can't factor that, so we'll probably have to use the quadratic equation for that one. Let's go ahead and let's look over here. Let's see if we can factor this one, though. Are there two numbers that will multiply to negative 6 but add to a negative 1? I think 3 and 2 will work if we use a negative 3 and a positive 2. So we can rewrite this as x minus 3 and x plus 2. So we were able to break that one down, but not this one. So we're going to go ahead and we're going to do the quadratic formula. So I'm going to go ahead and zoom in so we've got a little bit more room to work here, and we can see it a little bit easier. So remember, our quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So if we take our calculator, we can actually plug this entire thing into our calculator. I'm going to go ahead and just kind of break it up just so we can see it a little bit easier. And this is going to give us, sorry, on the inside, made that a little bit too big, a negative 36 over 2. Well, we know what the square root of 36 is. It's 6. And because there's a negative on the inside, that will be an I. So what we really have here is x equals 2 plus or minus 6i over 2. And so when we break this down, we actually can note that 2 goes into 2 and the 6. So we need to reduce this. So 2 goes into itself once, and into 6 3 times. So what we're really looking at here is x equals 1 plus or minus 3i. And so this is going to make up our factored form for x squared minus 2x plus 10. So we'll have 1 plus 3i and 1 minus 3i. And so that makes up the factors for our x squared minus 2x plus 10. And then we're going to have our x minus 3 times our x plus 2, and that makes up the factors for x squared minus x minus 6. Now, from here, looking at our factored form, or our product of factors, we're able to get all of our zeros. We kind of already found them here with our x equals plus or minus 3i, right? So we have x equals 1 plus 3i. We have x equals 1 minus 3i. But then, for here, we would need to use our zero product property to be able to find our last two real zeros, which are x equals 3 and x equals negative 2. And so here, we've now found all of the zeros. And so this is how you find all of the zeros of a polynomial when they give you one of the complex factors.